This is Kavita, the host for today's session. I hope everybody is able to hear me loud and clear. If may I get your confirmation on the chat window as yes, please. Very quick. Thank you very much for the confirmation. Let's go ahead and begin the session. So we have our trainer online. And before I pass on the access, so just wanted to keep you updated. The recordings are updated on your LMS. Kindly request you to access LMS to download the class recordings. So if you need any support, please reach out to help and support your LMS portal so that we can help you appropriately. Okay, quickly pass on the access to begin the session. Welcome to the session.
How are you?
I'm wonderful, I must say. Thanks for asking. How about you, Shubham?
Good, thank you.
Yeah, you're the presenter. Over to you.
Thank you. To everybody, a very good morning to all of you. Start today's session. Yesterday, basically understood, summarize, understood you. So, what I learned, we actually learned to understand what value is and to get into the calculation part, how we calculate the p-value and how we actually check the hypothesis. Those kind of things will come up. So, what hypothesis testing is all about and how we go on with the decisions, what are involved, uh, uh, we understood the two types of errors. So let's now build further on that and some problems as well. Screen now. Okay. So yesterday we were discussing problem which a businessman was facing. He was trying, he was evaluating different aspects, and he wanted to open new retail store. And he had that if the footfall per day will not be more than 5,000, he will open the store. For that matter, we build the hypothesis, null hypothesis, and alternate hypothesis. So mu less than 5,000, which was status quo hypothesis, and mu more than 5,000 was alternate hypothesis. We set up if he go for the store to the null hypothesis, make any action to reject the null hypothesis, rejects the he will make error. He will carry along some and is actually an error. So there is null hypothesis when actually it is true. So here is our decision. So these are our decision, and here is the reality: true or false. H not true, reality. H not false in reality. Something we saw, and type 2 error, and we were okay with these two. Got the example as well. We selected a sample, and from sample we found that the to be 5001. We consider example to be 5001, and we saw that it is against this. It is an evidence which is again a hypothesis, but we are not sure whether to reject or accept the null hypothesis. So, for that, looked into something called p-value. Told you that p-value is nothing but your type 1 error. Then looked into the concept of significance level. P-value, again you need to compare some level. Some people have more significance level, some people have less significance level. People, I mean to say, different organizations, their risk appetite. So take the significance level of 5%. Value is less than 5%. Null hypothesis. A value is more than 5%, then you okay. And if it is very close to 5%, if it is equal to 5%, then again you have to take a call, because it is all subjective. It depends on which you want to take along in your. We did in yesterday's class. We will be going further, and we will be solving one very interesting problem, and that will help you to understand these concepts better. So, before we get into the calculation, I will again giving you some tools so that you can solve that comfortably on your own. X bar is 1. Out the value of p. Get a normal distribution, because you would consider should be adequate enough. That is the assumption right now. Okay. Get it to a normal distribution with mean equal to the of the population. We'll get into a normal distribution where the mean would be equal to the mean of the population. So mean is 5,000. So you take this 5,000 as the mean to the maximum advantage. 5,000 as mean, and standard deviation equal to the standard deviation of the population divided by square of sample size, whatever sample you have taken. What you will plot are this file lies somewhere here, giving you some rule of thumbs. Then you would look at the alternate hypothesis. That hypothesis is more than 5,000. Look at this area on the right hand side. Is your p value. So this is the real hypothesis when actually it is true. So this you will do, you will find out the p value and then you can compare it with the significance level 5 or 0.05. So that is it what I have learned. In these two forms. Here I have it in this way: mu less than 5k and more than 5k. This alternate then you go for left tail test. Sorry, test value. You on the right hand side this x bar. See this is a division of the population divided by root n, and a t test it will be the standard deviation of the sample. Another condition, so this condition one, okay, which is right tail test. Whether right tail or left tail, that is decided by the alternate hypothesis. If more than mu more than 5k, then it will be for the area on the right hand side in the normal distribution. Equation like this: mu more 5k, a particular scenario, this particular case. In general, I'm just typing here cases which you might face. So, situation like this as well. In this particular scenario, you look for the normal distribution with mean is equal to population mean equal to the standard deviation of the population divided by root n of t distribution. It will be f divided by root n. then you would look at the area on the left hand side, left tail test. It will be left tail test. You see a condition like this. The third condition it is H naught mu equal to 5 H mu equal to 5k. In this particular scenario, you look at the area on both the sides. Will be five. The sides. Use this BOP value. So this test. A sample testing has three parts. Getting three types of scenarios. One tail. In one you can see tail. You can tail. And then you can have two tailed, in which you will sum up the two areas on the left and right. Let's get into the calculation to get understanding of how we calculate the p-value. So, to get understanding, I want you to look at an automatic bottling machine. Then I want you to look at. So it is to what we have discussed. How to apply these all concepts. So can solve you to give it like 1 2 minutes and solve it for question number 1. Test null hypothesis at an alpha of 5%. Have fourth type mu not equal to 5k. The third type only. You can I can go for different permutations, but logically if you'll think that is covered in the third part, there is need to go for the fourth one. The question is based. significance level. In that you will compare with the significance level. It tells you error you make in rejecting the null hypothesis if actually it is true. So it's you the risk the wrong. So or accept the null hypothesis on the basis of some evidence. Even after that, seen the future. Nobody knows what exactly will happen. So the reality might be different. You told you something, but the reality might be different. So that you can measure that uncertainty. You can measure, and that, you can take along with you. I will explain to you. Okay, Nagesh have come up with the answers. Bindu also solved it. Good. So three of you have solved it, and Nagesh has come up with the explanation as well. And I believe he close. See whether you people done it right or wrong. Your effort. Let so let's understand what this is requiring. An automatic bottling machine fills cola into 2-liter bottles. Consumer advocate wants to test the null hypothesis that the filled by the machine into the bottle is at least 2000 centimeter cube. It is 2 liter. A sample of 40 bottles coming out of the machine was selected. Exact content of the selected bottles are recorded. This was 1999.6 centimeter cube. Standard deviation is known from the past experience to be 1.30 centimeter cube. Okay. So this is given to you, so you must have understood the scenario. We do test the hypothesis whether the bottles the amount of cola into that or not, and that agreed amount of cola is a 2 liter. So basically, if you'll set up the null and alternate hypothesis, the process will be like this. You want to test the null hypothesis, so it has been very explicitly mentioned here. Test null hypothesis that the average amount filled by the machine into the bottle is at least 2 centimeter cube. Equal to or more than 2 centimeter cube, we don't have any issue. But if it is less than that, action. Set up the null hypothesis and alternate hypothesis like this, which is the very first step, and then also solve it. Bindu to solve it. So 1, 2, 3, 4, 5. See, doing pretty good on this, and those who are not doing good, they will be able to understand it after this discussion. Everybody comfort until point. Set the null and alternate hypothesis. Anybody any question? Good. No, they need to strong evidence, and we all agreed on that P is the most strong evidence because it tells us the error which we are carrying along. So the p-value, that is something we have understood. Here are scenarios. So scenario is similar to this scenario. Second scenario, the process tells you which access test you will go for. So alternate is mu less than 2000. So you see here you will go for left tail test. This normal distribution we take as 2000. You would take the standard deviation of the population given to you. Population standard deviation is known from the past experience. It is 1.30 divided 40 because the size is 40. We have been since ages. This is the normal distribution. See, is x bar. So x bar here is just equal to what we discussed. 199.6. So if you look at x bar, x is going other than the hypothesis. looking at this, I will say that the evidence is against the null hypothesis, but yes, I'm not sure whether to or reject the null hypothesis. So we got it. This will be somewhere here. 99.6. And discussion we saw, we look at the area on the left hand side. So A is less than 2000, so we will look at the area on the curve on the left hand side of this value of x bar. This area we would look at, this would look at is your p value. This we will compare with which is a significance level 0.05. If 5, we will reject the null hypothesis. If more than 0.05, we will accept the null hypothesis. This is the basic thing we have to do. So if we find out this area, it will be very simple. We learn this function p norm. So we are actually going rounds. We are taking rounds around this function only. P norm or q norm, pt and qt. So train point x comma this of standard deviation, and that's it. So this value, what p value coming out to be? 258. Wait. Nine point six, comma 2 copy sqrt. Two 58. That is right. Ajay, Nagesh, Sudesh, Bindu. It's very good. The basic thing we have to do. So P came out to be 0.0258. This value of P we will 0.5 because we need to compare it with 5% of significance level. So alpha is equals to significance level. So this we find that is 0.05. So we check the null hypothesis and we'll alternate hypothesis and go and do action. This is a left tail test. Left tail Z test we have done. So this example, but was very simple and was easy for you to understand. But we will be doing it on the data set, and we all know that test will be difficult to do because population standard deviation will not be known to you. Yeah. So 0.0258 is less than 0.05. If in 0.05, we can reject the null hypothesis. And the hypothesis is more than 2000. So it is not more than 2000. Take some action. So the conclusive statement in a business term would be to take action, because the advocate could easily reject the null hypothesis. It easily negate the fact that bottles are filled with at least 2000 centimeter cube of cola. So the of cola which are filled in the bottle is found to be less than 2000 centimeter cube. Some corrective actions will be taken with a business sense. Value is less than the significance level, we always reject the null hypothesis. That is something we learned. So it is the type 1 error. It is when you reject the null hypothesis and actually it is true. So this should be as low as possible. Action. If the p-value comes out to be more than 0.05, then not reject the null hypothesis. Not be able to say that these machines are faulty or company. All right, Martin. Phase. You would see the thing in part of this question. So one part, Chuchita, and let me know. So the p-value. Sushmita, p equal to alpha value, which is significance level of nothing, many definitions. is not the alpha value. Alpha is synonymous to significance level. B, which has come out to be 0.0258, this value is less than alpha. Significance level. Yes, Nikhil, I'll tell you. Yasu? Eight. If Rushita is right, I believe you are right. Null hypothesis is at least 2000. So go with the second type, which is okay. Come to your point, I'll explain the significance level. For the second part, we'll come to explain the significance level interpretation. The second part, that the population is normally distributed. Distribution assume sample size is only 20. Now, so sample size is reduced. Is the same. Okay, so sample size is reduced. So you can very quickly so if the sample size is reduced, that has come out to be 0.08, significantly more than 0.084. Yes, you are right. Very good. So the p value has come out to be 0.08, which is more than 0.05, more than the significance level. So won't be able to reject the null hypothesis. So one thing changed, that is cell size. Cell size has its reduce the power of decision. You should better take more sample. Yes, you are right. If the sample is 20, you need not to take any action. You Tesco is good. Okay. 20 adequate. See the big difference. But you have not read the question properly. If it says that the population is normally distributed, population is normally distributed. Distributed, you can apply the central limit theorem irrespective of the size. You are right. Okay, let's come to the significance level, which Nikhil is asking me to explain again. This level or alpha is 5%, and we take this value to p value. And value is nothing but the type 1 error. We are rejecting the null hypothesis, the error should be less. But when we say very less, what do we mean by that? So it have some we should compare it with the possible uh, taking abilities, what risk I can actually take along, what we are into the permissible limits of the company. So that matter, we introduce the significance level. So significance level is the permissible level of error to take decision. We consider as the permissible level of error. Okay, that we can take along that significance level. Nikhil, sense or asking something else? Right of the organization to take particular decision. 8 point, which is okay. To make 5%, yeah, deviation point, you can call it a risk. Call it, yeah. So 5% is 5% deviation here and there. Yeah, you are right. I have done it on these very small samples. Let's do it on a data set and there we apply these. We do it on a data set. We always use these formulae, but uh, these formulae will be difficult to use if we have huge data set. You have to find out the number of rows separately. Instead of doing all that, we directly use the test, deal with the data set. That directly gives us the value of P. Has a question, but based on this example, how we can write on the sample size. So that is a very important point. So we looked at two scenarios. In one scenario, the sample size was 20. In another scenario, the sample size was 40. We had a larger sample size. Then in decision, p-value, and when we had lesser sample size, we got different p-value. The to take the larger sample size always is reduces the power of decision. So take the larger sample size. The reason to take along the larger sample size is also to have more number of scenarios. Sample size means you are taking more variations of the data. Analysis will in, will accumulate more type of variations, so your result is more robust. So larger sample sizes. Or you are asking something else so that I can rephrase. Your concern is very genuine. Third scenario, it will be difficult to judge when you have taken uh, size of the sample or not, whether analysis is correct or not, because here you saw the completely different. uh, So I'll give you the example for this. I discussed this with you. Sample size. When about the outliers, I discussed this thing with you. So that analysis involved too many things. So I only considered the 6 month, and from that data of 6 months, I found some values of sales to be very high. Values we were looking at, those came out to be as outliers. But when I showed it to those who knew business better than me, they said that these values are pretty rife, getting these kind of values. So since you have taken the data, taken the sample of last 6 months only, because that you are looking at these values and you are finding these values very high. These values are not high. If you will take the data of last 2 years, then you will not be able to get the values as outliers. You will see a lot of other values very close to these values. It is very subjective, and it requires business acumen, business knowledge to test, to check whether sample size is adequate or not, whether the sample has uh, all the ways, all the type of uh, those or not. Basically, you want your sample to population the best possible way. No mathematical technique as such. There are some formulae which I can tell you which are dependent on kurtosis and skewness, but those formulae again fail when you come to the business sense, because in some business, in some scenario, thousand observation help you. In some scenarios, even 5,000 won't help you. So mathematically, it will be difficult. But yes, you have to apply your subjective knowledge, your business knowledge, and you need to see whether your sample is representing the population the best possible way or not. Objective, it is actually not a very simple decision to take. And try to make sample as large as possible. As of this reason only, people are having some good industry understanding. Uh, People who have good domain knowledge, they always consulted. Other the looking at these values, you keep seeing whether a sample is actually representing the population or not. So the bottom line is uh, the sample which you are creating, that should be able to represent the population in the best way or not. That's the only thing. And go further because I have been a part of decision taking teams. I've been in many big decisions for some big organizations. So I'll tell you how big companies take decisions. So mathematical uh, conclusions are one dimension for sure. They are very important dimensions. But decisions are not only taken on the basis of only mathematical dimension. There are other dimensions as well which are taken into the consideration. So no decision is taken only based on the mathematical dimension. Other dimensions as well which are taken into the consideration. But critical dimension is one very important dimension uh, to consider taking any big decision. Now, I want you to the data HYP, which I shared with you all. HYP, I want to import that data. Yeah, just sharing those links again. Data from this link. Thank you. So, see how actually do it. So, we spent a lot of time understanding what p-value is, how to calculate it. Okay, so those kind of things we learn. Now it's time how we quickly do it on the data set. Okay, do it quickly on the data set. You actually don't need to go for these kind of formulae. You have a function called t-test. Directly use t-test for that, and be very simple. So test is the name of the is this formula here. So H file, it will be math in math 1. So I made some changes here, and you want to check the hypothesis that the matrix marks scored by these students are at 52 are equal to 52. So the null hypothesis will be equal to 52, and alternate hypothesis will be mu not equal to 52. So it will become a two-sided test. So it will be two-sided test, and once you will run it, it gives you the p-value. Let me take you through what all we have in this. So will question mark, and after that t dot test, and it will take you to this. You can see here you can mention two-sided and grid as well. So you mention it is a left tail test, creation when it is a right tail test, and you mention two-sided when tail test. Okay. Also have some other options like paired. I also mention the confidence interval. It also gives you the estimate. See, it also gives you the estimate. So it will take 90%, 95% confidence interval, and it will give you the estimate for the population. So it gives many things in a go. You need not to calculate the values of sample standard deviation, those kind of things. Everything will be calculated and get the answer directly. Okay. Other things we will look at in it, but this is something we can do on this t dot test function, because we use t test. For hypothesis testing, we don't go for z test. T dot test and hyp dollar math 1 mu equal to 52 and alternative two-sided. So for addition, I have taken only two-sided test. So here is coming out to be 0.33. So you look for other things like degrees of freedom 199. You have two observations. Degrees of freedom will obviously be 99. So you know to calculate these things. It will look at the data. It will fetch from the data itself and give you the results. It has a value for you as well. D has calculated for you. That it has calculated the p-value for you. Alternative, it is mentioning that alternative hypothesis true mean is not equal to 52. Mu why from the data set, Balaji? Was that 5,000? What is it is the population mean. So just this thing yesterday that we set up the hypothesis only on the population parameters. We check the hypothesis only for the population. So these population parameters, and I discussed, I believe, at length. Okay, take care. Everything would be well, as well. Take care as well. Don't. To the question of Balaji. So we discussed yesterday that we always set up the hypothesis statement on the population parameter, and discussed at length yesterday that 5k, this 5,000 value, how we arrive at 5,000. So 5,000 is something is the assumed value. This value can be coming from some break analysis. So case when we were opening the store, we must be doing some financial calculations as well, and from financial calculations must have arrived some uh, value for visitors, number of footfalls must have been coming from that analysis. So this is assumed value. So if you talk about this 52, here must have been coming from some my own analysis. These people will go around 52. So my assumption, this is my hypothesis. This has nothing to do with data, with a sample. Okay. So that so please keep asking questions. I will definitely mention a point that I have discussed. I have clarified it. But yes, if you'll ask me, I will surely be telling you again. Okay. Good. Thanks for asking. So it was about sample. Alternative is nothing but the alternate hypothesis. So yesterday we discussed this thing that hypothesis is a statement we make with null hypothesis and alternate hypothesis. So null hypothesis is your status quo, and alternate hypothesis is just opposed to that, keeping in mind that both will form mutually exclusive and collectively exhaustive statement. So alternate hypothesis is just opposite to null hypothesis. So null hypothesis is mu is equal to 52. The alternate would be mu is not equal to 52. True means population mean. Two have discussed it here. When we situation like this, mu 5K. We go for two-sided test. Marks getting by student is 52, is it not? Yes. You have to conduct for 99% confidence interval, then what t we go for? When anybody asked you to conduct a test for 99% confidence interval, that kind of a statement. So, and hypothesis testing. Alternative station. So, scenario, the will be like this: mu is equal to 52, mu 52. Not, and this is your HA. So, A value is coming out to be less than 0.5, then you will reject the null hypothesis and you will say that mu to 52. That the average marks are not equal to 52. Uh, what I said, mixing the concepts. Why? Uh, take up the confidence interval to estimate for the population from the sample. If we have been given a sample and we need to estimate for the population, we take the confidence interval. We create the confidence interval. Here, in case of hypothesis testing, I never told you about the confidence interval. Talking about the significance level. So, if significance level is so if the confidence interval is 99%, significance level will be 1%. So we compare the p-value with 1% of significance level. So whatever p-value will come out, that value will be compared with 1%. I mean to say 0.01. And if it is less than 0.01, we will reject the null hypothesis. Otherwise, we will accept the null hypothesis. The result part. Okay. Look at the result. It is mentioning that the data which it is considering is math 1. For me, math 1. For you people, it must be math only. The t value, you calculate t value, degree of freedom. Then from 10 degrees of freedom, you can calculate the p value. So we will look at the p value because we have done a lot of calculation using these all things. So to get into those all things, we will look at the p value only. Just saying that alternative hypothesis is this, true mean is not equal to 52. That is what alternative hypothesis is. 90% confidence interval it has taken to estimate. So if you are taking 95% confidence interval, the will lie between 51.3 to 53.95. And found out the mean of this sample has done. So you will do manually. It has calculated it with the help of this formula t dot test. Bit clear? Able to understand from these all? This is carrier. I doubt is true mean 52 in this case. Okay. To point. Let me answer is carrier's question. I have a doubt. Okay, so not equal to 52. What does this mean? It is an alternate hypothesis. So for this particular thing, what we are doing, we are checking the hypothesis whether the average marks of the students is 52 or not. How we actually do it? The scenario. Let me put the scenario. I am visiting a particular area where we have different schools, different programs, different type of students. From my own experience, in my statement, rating, but the age marks is scored by these type of people, these type of students, is it true? This is made. Okay. This statement which I made from my experience, this statement is being checked to this sample of 200 two students have been taken into a sample and this statement is being checked. So the null hypothesis for this statement would be mu is equal to 52. This is mean. Population mean is also called as true mean. Called as true mean. General mean basically. It would be mu not equal to 52. Mentioned here. Good. Okay. We need to so we need to consider x versus mu. Then whether reject and no. You have to look at the p-value. Mu incorporates this which you are mentioning. It incorporates sample mean versus population mean thing. We calculate p-value. I told you how we calculated p-value. The calculation involves of population mean and the sample mean. So we only need to look at the one error which is p-value. That is which help us to take any decision. So you need not to look at any other thing. It is throwing out, it is spitting out many things which are not required at this time. Like it is spit out this confidence interval as well, which made some people confused as well. Aditya got confused with this only, I believe. So but confidence interval has been taken here and it is throwing here directly two values. Why I mentioned it here? Because t test is not only used for hypothesis testing. It is also used for finding out these estimates. So we did a few questions. In those questions, if you remember, what all we did? Uh, just a minute. What all we were today? We found out X bar separately, found out sigma separately, then we calculated the degrees of freedom, and then we went about these kind of calculations. Okay, but if you are using this function, it will directly give you the estimate. Directly get the estimate using t dot test. But I would have told you this function at the outset, you would not learn those which you learned by hard ways. So this is giving you the estimate part as well, giving you the mean as well separately. It is mentioning what is the null hypothesis, what is value, what is degrees of freedom, and what is the p value. So be interested in the p value, which we will consider to take decision. Let's clarify. Good. Instead of two-sided, you can also type greater and less as well. So that is something I believe you can do that. Any value within the confidence interval will be the alternate hypothesis be true. Only within the confidence interval will the alternate hypothesis be true. Use yourself. Not mix the things. You write that way because it is containing those elements which one error, and the things are containing those elements actually true. Say that the average marks is equal to 52. Yes, because the p-value is coming out to be 0.33, which is more than 0.05. Okay, the null hypothesis. No, just hold on. I believe. So what is mu here? Sorry, what is the null hypothesis here? Null hypothesis is 52. Just on the statement, I believe. Mu to 52, the alternate is coming out to be 0.3. One. It is more than 0.05. You are not able to reject the null hypothesis. So accept the null hypothesis. Is less than 0.05. To reject, you will null hypothesis. Then we learn p will be as less as possible. if we are going for an action. So here the p-value is more than 0.05. We will be able to reject the null hypothesis. We have this which is 52. Okay. Any confusion in this? It is 5%. Good. So now done with one sample t-test. To do test, right tail test, two tail test. Let's do two sample. When we say two samples can be of, we can see two types of scenarios. Scenario can be paired. Scenario can be independent t-test. Talk about paired t-test. Paired t-test means we are considering the same type of respondents. Time the scenario, one session I'll put forth to explain it further. You want to test uh, a medicine is effective or not. Will do. Suppose you are medicine for blood pressure patients. Okay. Basically, you are creating the medicine for to test whether it is effective enough or not. So we will check the blood pressure of different patients. Okay. Before the medicine, and the blood pressure of those people after the medicine. Now the respondents are same. Okay. Giving you two samples. One you are getting of the blood pressures of blood pressure records before the medicine. Another sample you are getting blood pressure record which you have noted down on the medicine. You have two samples, but those two samples are coming from the same kind of respondents. So in test, I'm talking about pair t-test. In pair t-test, you get sample of kind of respondents. And in this case, if you will observe, the sample size will be the same, both the samples. An example, uh, NPS study which I discussed yesterday. So you uh, went to the survey, you collected the scores, and after that you ran some marketing campaigns, some promotional campaigns. You want to check whether those promotional campaigns, those marketing campaigns are effective or not. You will NPS. So what you do, you will compare scores of the merchants before the survey, before the campaign, and after the campaign. If difference in the NPS score before the marketing campaign and after the marketing campaign, then the marketing campaign must have some impact, otherwise not. Thing on successful. You just before the advertisement, you lead advertisement campaign. Okay, sales before advertisement campaign and after the advertisement campaign. If you difference, then the advertising campaign was effective enough. Able to understand, how many of you are not able to understand the pair T test? And the company will also fall under this type. Then sure, employer within the company will also fall under this type. Suppose you want to check whether new suppose you have introduced new processes in the performance appraisal. Performance appraisal cycle, every 1 year in organization you have these cycles. Used some new policies, new procedures, some new processes, and you want to check whether new processes, new procedures, new things are did well by employees or not. Employees are happy with the new things or not. So you will take a section survey of the employees before launching this and after launching these new things. You will compare this test. Compare the before and after results. This test result. Then for pair T test. You have come here to learn stats, to analytics. Okay. Coming to these classes, your conducted one exam for people before join the course. Okay, some questions were there, and you require to answer those questions. Through the whole program, going through the whole program, all these classes are conducted to check whether you have learned enough or not. This thing will have impact on your understanding or not. You again conduct one test and then to compare pre-test and post-test. This is an example of pair T test. Since the respondents remain the same, sample size will also be the same. I'm reading Nagesh question. Before joining the course, sample is 10, but after the course, few people did not give feedback, so the sample is 8. Here the sample size is not same, but we have before and after result. How to conclude this? So, to our question, we often face this kind of problem in our organization. So, third method is to compare only those people who tested before launch of the campaign. So people who gave exam, only those people are paired with uh, people are compared. Okay, so suppose sample to match. So people who wrote the scenarios for the test and after the test. Sorry, before the training and after the training. And confusion in pair test to independent t-test. Independent test. Uh, you can think about employees uh, sitting in different countries. We want to check the performance of those employees. So there is one test for that sitting in different geographies. Okay, so the few employees who are sitting in USA, employees sitting in India. Okay, we conducting for the employees who are in USA and one test for the employees who are in India and comparing whether significant difference between the two or not. Then go for independent sample t-test. Another can be girls. You mathematics marks of girls and boys. It will again be an example of independent sample t-test. Here again you have two samples. One sample will be for the boys and one sample will be for the girls. That will be uh, one dependent t-test. Okay. You have two schools and where the tools mathematics marks. Again, you have two samples. One sample will contain mathematics marks of school and another sample will contain the mathematics marks of school 2. Again, comparing that will be independent sample two sample independent t-test. Any confusion in independent and pair t-test? So adequate enough. So, Ruchita, to understand PAT test, I'll give this example. Suppose uh, Adit, Sudesh, Baji, and Ruchita. There are four people, okay, who go for training, okay, uh, train analytics. So I have Adit, uh, Sudesh, I have Balaji, and I have Ruchita. These four is I have. They went for uh, subject course. So this course, let's take the example of this course only. Their test was conducted. There was a mathematics test that was conducted for them. Before joining, they were given some question and they were asked to answer those questions, and they got some marks. 2012 to something like this. So they got these marks. Went through the whole sessions. They understood the concepts. They appeared for the project. All things they did, and once done with the whole course, they're again done. And the marks again. Okay. This is the pre-test, post-test. So there are two samples. One sample is this, another sample is this. And the first sample will be from the pre-test, and the sample will be of the post-test. Now then you are comparing two samples now. I'll show you how to compare. I'll tell you the methodology, but this is about the pairs. Could you understand, Ruchita? Good. Yes, son is right. Always try to have a comparable sample sizes. So, very valid point that we are taking only 10 employees from USA and 100 employees from India does not make sense to compare. Sample size would not be same. Try to make it very same. There will be deviations in the sample size as well. So, Lokesh is saying, but as per the rule, sample size should be taken as much as possible. Be taken as big as possible. Okay. The bottom is not to take sample size as big as possible. The bottom is to take the sample size, to take sample such that it can represent the population in the best possible way. So size should be can big as possible so that to to accommodate as many possibilities, as many variations as possible. So collect too much sample and all the observations are showing the same kind of variation. That is again not that not give you tangible result. So have sample size big enough so that the objective of having a big enough sample is to have as variation as possible, many CEOs as possible. Let me come to the okay. So I'm not deviating from that. We uh, we would be companies as long as the sample size is adequate, it should be fine. Yes. So we should not keep adding the redundant scenarios as well. Example, you want to compare the performance of uh, simple example. You check the satisfaction level of people of your team. Okay, to check satisfaction level of the people of the employees of your company, you have to pick the sample, and your company is spread across different geographies. Okay, you can do uh, you can take you and you are asked to take the sample of around 2,000 people. That is the constraint of the budgets because of the time. So you need to take 2,000 people. Now, 1,000 people, if you take all the people from the same country, that's the redundancy. You should have as much variation possible within your sample. So you should take people from different locations, from different geographies, some portions. You should also look at people from different bands. You should also consider the portion for girls and boys. So those things you need to take into the consideration so that your sample can represent the whole population in the best possible way. Okay. So take the sample of 2,000. You make 2,000 people set of 2,000 employees. So it can represent the whole company. So in your company of girls and boys is like then you would have 50-50 proportion in your sample as well. If there's and the same goes with bands and for different geographies. That's the whole point. So it's not about only increasing the sample. It's about increasing the sample. We have as much variation as possible in the so that the sample can represent the whole population. You got it? So do both the tests in this. And you tell me let me open that. So look at it. Let's start with independent sample t-test. Independent. Uh, can you scenario? Let's take it up. Suppose to compare the mathematics marks for girls and boys, and you want to see whether there is a significant difference or not. What you do, you can take t dot test p dollar math one. If it is math one, is it different? It would be math, and then you can mention gender. Tagesh. So what happens with me, I also realize is I keep revisiting my own lectures and lecture as well. I always prepare for the class. So when I introspect, I see sometimes I over-explain as well. I explain sometimes more than required as well. I believe is safe to some extent uh, to go back and keep some points. Uh, uh, Sometimes I over explain, so please bear with me. Those people who know the things already, but I believe it will be helpful. Over, but it is safer to open than to explain. Okay. So if you'll take this example, good Nagesh, and the objective is the same. You have to apply these all things into the real life scenarios, which you will be able to do when you will discuss these things, and I will share my experiences with you. Okay, thanks. So this is the independent sample t-test. Again, you see here, you need not to do much. You are mentioning here test. So in US it must math. So please correct it. So math one is the variable of interest. You are mentioning tilde. After that you are mentioning gender. It is doing, it is automatically creating samples. One sample, first sample will be for the male, another sample will be for the females. You have to do it in cell. This is a tedious task for you. I'll show how. You have to do it in Excel. Aman, yeah, thank you. To do it in Excel, add two cells like this. Be for the boys, say presented by for boys, you will take out sample. Do in Excel. I'll show you. This is simple. Boys, and what you will do, you will take and then take another sample for girls. Then you create two samples. A pretest in Excel. And go analysis and a t-test. The t-test is given at the bottom. Okay. I could not understand your point. No need to look at average. We can see these results. Yeah, I know. That knows. I'm showing you how you can do it in Excel. You create these two, and they have to go for data analysis. And in analysis, you have to pick up, and you mention these two ranges. That is what I am showing. We all can look at the count, sum, and average at the bottom. Is that why I'm just showing you how you can do the t-test in Excel. Okay, so go to data tab, have this data analysis. You can create this to you because sometimes you have to use Excel as well. So I'm showing you this data tool pack. It is actually very helpful when you don't have these tools or your clients don't have these tools. Suppose client is requesting Excel result. He is comfortable with Excel. So you use Excel as well for these basic things. That is what I wanted to show you. Okay. How you don't have this data analysis tool pack? People who don't have what they can do, they can go to file. This an option of Excel options. What version you are using, you must be having Excel option. Go to options, and options you need to go to else. Yeah, Praveen. You go and on go here at bottom. I'll show it again. File, if you are using Excel 2000, and I believe you people are using Excel 2007 and beyond. In 13, I mean, so you can go to file, or if you have here, if you're using 2007, I believe there is some circle here. You can click on that and you can search here somewhere. You will get Excel options. That you can do else, which is in the left hand side panel. Then go at the bottom, and then click go. Here says toolbar and hit OK. Hit OK. Data analysis will be installed in the data tab. Okay. It. Did you options? No, data. You need to go to either which version you are using. 15, 2000 soft. Then you should be having similar look and feel. Right? 2000. Okay. You need to click on file. That is what I have been doing. Click on file. At the have options. Click on options on the left side panel. Then and here go and click this toolbar and solver add-in. Click OK. It will add it automatically into your data tab. Data. Added the add-in but can't see data analysis on the data tab. Maybe the limited version of Excel. Maybe try it again. Okay, anyways, how would you do that? That is what I wanted to show you. You have multiple options. After 1 minute, I'll give you the break. Two samples assuming equal variance. Now you have two options. Paired you can't go for. We all know that two sample independent test. For independent t-test, it will ask you for two things. They have equal variances or unequal variances. Check the variances. You can check, and if the variance are very close to each other, then you can go for equal variances and then hit OK. Select the second option. You have to give the variable ranges 1 for 2. Okay, this you will give hypothesized mean. You can mention what as mean you want to see, and then get the results. Let's show you. So this variable range, second variable range, hypothesized mean difference is 0. You want to see whether there's a significant difference between the two or not. You have labels in your data. If you need to mention, you can mention the output range within your like this and hit OK. You get things again here. Okay. So now you can do it on Excel. You can try to look at it in R. Basically, I wanted to show you it in Excel just to give you the feel of how you can do it on Excel, because sometimes you need to use Excel as well. Okay, so, I'll be dealing with pair t-test after the break in R. Okay, I'll be talking too much because you ultimately need to learn it on R. I only showed it to you so that you can explore. Okay, so see you after 10 minutes. Uh, Coffee and come back. Thank you. I think in Excel, Martin, we will see some very advanced techniques which we will not be able to do in Excel. Yeah. Okay. Let's take these all things after the break. Okay. response. So back very we have to start the session. Thank you. So that was about independent sample t-test. Let me share. At this point, I would like to tell you, let's not get too much into the details. Because we only need to look at p value. Why I'm asking you not to get into too many details? Because if you look at the DF, degrees of freedom, coming out to be 187.58. So when I discussed about degrees of freedom, my objective was to give you the idea about what degrees of freedom is all about. Go for the two t-test, and then you will go for 3 samples, 4 samples as well. Degrees of freedom different. The will become different. Like for 2 sample independent t-test, degree of freedom is calculated using this big formula. Divided by n1 plus. So a big formula is there to calculate it. I don't get into too much of mathematics as such. S1 divided by square and minus 1. Okay. Plus. You get these kind of formulae. Calculate the degrees of freedom. Statistical books. So that is not a big deal. So it is automatically calculated for us by the tool. So need to worry for that. Okay. Talk about a paired t-test. If you take the paired t-test in this particular scenario, that I did back, converted this science into math 2. Science to math 2. I changed the head name. So 1. So math 1 are the score the students before the training. Math 2 are mathematics marks after the training. And now you are comparing. So again you see here are the mathematics marks before the training, and 2 are the mathematics marks after the training. And we want to check whether the training is effective or not. There should be a significant difference between the means of math 1 and math 2. Extensively in healthcare and in research forms. You're right. So math 2. So respondents are same, number of observations will be the same, and you can do it easily. So test HP dollar math 1 dollar math 2 in paired into true. By default it is false. You can paired is equal to true. So give you the pair t-test, and you will see the p-value coming out to be 0.1768. So this, both the null hypothesis is like this. Not is 1 equal to mu 2 and mu 1 not equal to mu2. This is a hypothesis statement. Okay. So it's about one sample and two sample. It is about three samples, four samples. Suppose we have three samples. We go about that. Suppose four samples. How will we go about that? Let's discuss about that. We have more samples. Hypothesis which we need to test would be different. The hypothesis would look like this. H mu is mu2 to mu3. Not all equal. Okay. So how do you test this kind of hypothesis? You can multiple t-tests. You can go testing for these two, then testing for these two, and conclude the result. Actually, we don't do this. And you tell me why we are not going for multiple t-tests. Why not going for 2 or 3 t-tests to get to the result? Can you get? And a very commonsensical look at what you have done in t-test. It will give you the answer. Point. How many of you could not understand the problem? We'll do is something different. What we will do, but we are not able to do t-test is something which I am asking you. To you is, if we have 3 samples, then we have to compare 3 mu1, mu2 and mu3 samples. Basically we need to compare 3 samples. What we can do, we can go for multiple tests, because test is done only until 2 samples. For 1 sample you can do t-test, for 2 samples you can do t-test, but 3 sample we do something else. What we can do, we can divide this problem into 2 pieces. We go samples, sample 1, sample 2, we can compare means of sample 1 and sample 2. Okay, and we also do the sample 2 and sample 3, and then we can finally state our analysis. This is one way of doing it, but we don't do this way. We don't go for what reason. That is what I'm asking for. Or I have to be analyzed together. Order in which the tests are done could matter. May be different. What will do is not the question. Ask any question which you have not done. I will only ask you the question which you have done. ask you to compare 3 samples. How do you go about that? You get the p-value for different tests. You can go for 3 t-tests at 3 p-values. 3 p-values, from 3 p-values you will get 3 results, and you pay those results to finally say about the hypothesis. Okay, let's discuss this thing. You see, if you think about this problem, we are getting multiple t-tests. We have to come up with multiple. It will be for sample 1 and sample 2. Another t-test will be for sample 2 and sample 3. The third one will be for sample 1 and sample 3. 3 t-tests we have to do. If you and of these 3 t-tests, we have to make a decision. Result. If you see here, we will come up with 3 p-values. What value? P-value is error. Is the error which we carry. Actually, for multiple t-tests, you are dividing your decision into 3. Your decision will carry multiple errors. You will see here. One you will get from 1 t-test, an error you're getting for second t-test, third error you're getting from third t-test. So 3 errors you are getting here. And those errors are getting multiplied the result. So possible level of error is 5%. You are giving the permission for 15% of error. So for multiple t-tests, you are actually multiplying the risk. So and the error will be much more if you are going for multiple t-tests. Instead of going for multiple t-tests, you actually go for analysis of variance. You actually analyze the variances, you compare the variances to arrive a decision. You don't go for multiple t-tests. Instead of multiple t-tests, you actually go for ANOVA. Makes sense? Because this is a favorite question. My favorite question which I ask in the interviews. You are not able to understand. So what I said, when you conduct any t-test, you take on some error, you take on some risk. Okay. Or multiple t-tests. So you are getting multiple errors. So instead of carrying along with you multiple errors, you do new method altogether. That the error which you are getting through multiple tests that can be avoided. For that, you go for analysis of variance. Analysis of variance will help you to get rid of multiplying the errors. That's what I said. Now, and Ravi, did not understood. I will rephrase or explain. Okay, so it's turn to understand. Okay, with an example. I have these three programs here. I need to compute the mathematics marks for the three programs. Null hypothesis here would be oh null B is equal to mu for first program, mu 2 is for second program, and 3 is for the third program. This what you are multiple t-tests. So t-test with some p-value there. There'll be p-value from this t-test as well. So you are going for multiple errors, multiple type errors. That is what I am saying. Avoid, and for that we want to go for ANOVA. Bindu. So three programs, you are getting three samples, and let's see how we can go about that. I try to explain you what ANOVA, avoiding mathematical calculations. Can you the whole calculation part as well, because this is something I've been doing since ages, but that's required. So basically, what we have in ANOVA, we have samples: one sample, two sample, and three samples. These are the marks of different students for program 1, for 2, mark your x1, x2, anything. So calculate where again null hypothesis and alternate hypothesis will be checked using the p-value. Now how we get to p-value? So the hypothesis here is mu is equal to mu 2 to 3. Is all not all equal. Okay. Check hypothesis to reach p-value, value here it is. To get a p-value here, if we've already learned z parameter, we have already learned t meter. With the help of z as well, you can find out the p-value. With the help of t, you can find out the p-value. Now introducing another parameter that is called f statistic. So t statistic you have learned, z statistic you have learned. Now I'm introducing another statistic which is called f statistic. Statistic is equal to group variance group variance. So statistic is the ratio of between group variance and within group variance. So look at these two things, between group and within group. Within group variance. So if you are finding out the variance within these groups, I'm talking about. So you have these three groups. Within group, if you're finding out the variance, that is called within group variance. It's in between. It's called between group variance. So if there is significant difference between the population of these three groups, then the between group variance would be much more than within group variance. Don't you agree with me? Statement. If there is a significant difference between the groups, the between group variance would be much more than within group variance. Don't you? There's something obvious if you understand the concept of variance. So what to say is this ratio would be about difference between the groups. If the groups are very different, the ratio will be very different. F ratio, from ratio, you actually calculate of P. To those formulae again. So we learned P norm, we learned Q norm, we learned PT, then QT, then you have FT. So those you need not to go for, because now we have awesome formula. You have already understanding of how we calculate all those things, how that area is calculated. We have gotten into that clarity already. So uh, which will be calculated by the tool itself. You need not to worry about that. Between variance, the tool will calculate. Within group variance, tool will calculate, and also calculate the p value for you, that you can come and get the result. So let's the program only. So the name of the formula, analysis of variance for one again the same thing which you did in t-test. You're mentioning the variable of interest, but the all is converting this program variable into a factor variable. We will understand what factor variable is when we will get into the data structure of R. Be a categorical thing. So you are actually fetching categories which are in the program. This is what you are doing with this as dot factor formula. Once you will run it, the analysis will be stored in this object out, which you can easily use a summary function, and you can look at the probability value to get the conclusion. Those two lines, let the output, and then let's discuss further if required. This ratio, it will to be 2000. Okay, dot factor factor is used to convert the variable into the categories which is containing. So it is containing three categories. It will convert this into the categorical variable, into the only. Okay, so I give you the factors. To understand more of it, once I will discuss data structure of R. Yeah. So programs level 1, program 1, program 2, program 3. Three. If two variables are m and equal, then what in AOV command? So seeing here this ANOVA, when we have three samples, so we have uh, if you have two independent, there are in the result you can see here. Just we have programs here 1, 2, 3. There are three levels. So this ANOVA, so you look at the p-value, you need to look at many other things. You want to look at the p-value. P-value is 7.36 into e raised to the power minus 12, and there are triple asterisks there. So it is about the codes. So if value is very close to 0, then you will have 3 asterisks. If it is close to 0.001, there will be 2 asterisks. If close to 0.01, there will be 1 asterisk. If it is 2.01, there will be dot. So you have 3 asterisks. It simply means that the value is way too close 0. So it will be way too less than 0.05, and hence you will conclude that hypothesis. Okay, the marks are significantly different from each other. Your null hypothesis. The null hypothesis was mu1 is equal to mu2 is equal to mu3. So that you are rejecting. So there is a significant difference between the programs. That again. So what I'm here, p-value. You need to look at the p-value. The p-value here is coming out to be 7.3 e raised to the power minus 12, which is very close to 0. 3x are given here. E is an exponential. The size is between 2 and 3. It is a rational number. E to the power minus 12 is a very, very small number. Very 0. The obviously very than 0.5 as well. If its value is less than 0.05, the significance level, we get the null hypothesis. The null hypothesis was mu1 is equal to mu2 is equal to mu3. So we can always mention now that the mean values significantly different. The mathematics marks of the 3 programs are significantly different from each other. Okay. That's for ANOVA. In terms of hypothesis testing, last bit which is remaining is chi-square test. Take you chi-square test as well, which is actually very important. Ask any question. Okay. So, and I have suggested you that book. In the book, if you'll go for ANOVA, you see some calculation part as well. How these calculations have been done: sum of total sum of square, residual sum of square, which is called as error sum of square, and so these all have been done. Then the number is divided by the degrees of freedom. So it's a big calculation. So that calculation, if you wish to. Any problem, if you have any question, you can always talk to me in the class. I will take up that thing. But I don't find any value discussing that mathematics that calculation here in the class. Converted program into a categorical variable. So it's actually a categorical variable only. actually took out its levels only by converting it into a factor. So it fetched out its factor only that need of that function, that AOV. In AOV we have to keep the levels that I converted it into the levels. So about chi-square test, and I have to get into the calculations of the chi-square test. I have no option for that because you would need to do some calculations over there, and that's why let me open the slide for that to make it easy for you. Mm, sec. Yeah, the concept of chi-square and its application. This is it. We have understood Z statistic, we have understood T statistic, we have understood F statistic, and now in last bit, it is chi-square statistics that we need to understand. And after that, we will be good to go for advanced techniques, and we'll start with regression after that. This case and to explain it, share. This I believe. City has a newly opened nuclear plant, and their families is staying dangerously close to the plant. A safety officer wants to take this case up to provide relocation for the families that live in the surrounding area. The case is strong. He wants to prove with numbers that an exposure to radiation levels is leading to an increase in diseased population. He formulates a contingency table of exposure and disease. So this type of table is called contingency table. Does the data suggest an association between the disease and exposure? Data is all about, let me tell you, 37. So 37 is the number of people of the exposure to this nuclear plant who are staying very close to the nuclear plant and are found to be diseased. 30 is the number of people who are exposed, who are very near the nuclear plant and found to be diseased as well. Okay, and 17 and 57, 53. 17 is the number of people who are living far away, who are in very close to the plant, still got caught with the disease. 50 is the number of people who are again staying away from the plant, they are not found to be diseased. If you look at these numbers, you just can't take any decision again. Few things which might go against the null hypothesis. The null hypothesis here is exposure and disease. They have any association between them. This the null hypothesis. So test which we are going to do is also called as the test of independence. In this test of independence, we check whether two variables have some association between them or not. Let's do one more thing here. In chi-square test, always check the association between two categorical variables. So we have two categorical variables. Here we have two qualitative variables. So disease and exposure, these two are categorical variables, and I want to see association between the two variables. The null hypothesis, again I will mention, the hypothesis is that the two variables are independent. They don't have any association between themselves. So look at these numbers, you start drawing some conclusions, but you will to come to a conclusion and that there is a big association between the two variables, and you start relocating the families. How many could not understand? How many not understand the problem statement? Please let me know. Okay. Balaji. Anybody else? No, categorical winning correlation. So here we are looking for the association. And it's done to compare the population which has three samples, more than two samples basically. So ANOVA was used to compare the populations, three patient, four populations. Not comparing. Here, looking at the association between the two categorical variables. That's it. Ish, Balaji, Adi, and Praveen, four people. Uh, let's discuss this thing. Why you could not understand? Could you please point out what exactly you could not understand? All of you, it will be helpful for me to. Uh, if you can point what you could not understand, or you could not understand the whole idea. Not understand the whole idea. Uh, Aditya, how association is applied and what uh, table not clear. Okay, I'll explain you the table. So exposure and disease is independent. Yeah, and disease, these two are independent. It's dependent, but we need to check whether they have some association between them or not. Okay, so enough to tell it yet again because chi test, I will reiterate, chi-square test we use when we need to look at between two categorical variables. In this case, we want to check where people who are from some disease suffering from this disease because they are located near the nuclear plant and the pollution used the nuclear plant is responsible for that disease. Something I want to check. So, a new nuclear plant, there are families staying dangerously close to the plant. So, health officer wants to take this case up to provide relation to the families living in the surrounding areas. To case is strong, he wants to prove with numbers that the exposure of radiation level is leading to an increase in diseased population. So, come to that conclusion. Are we till this point? Praveen? Okay. Now to check this thing, what is done? Contingency table is created. Contingency table contains the frequencies. The people. So if you look at these numbers, how you interpret these numbers, how will you read these numbers? I actually read all numbers for you. I will one you and I'll check whether you have be to understand or not. So if at this number 37, what is this 37? There are 120 people who have analyzed. A sample of 120 people have been taken. Okay. So of 120 people has been taken, and of 120 people, 37 people diseased and very close to the nuclear plant as well. Yes, they were posted back to the nuclear plant and found to be diseased as well. Yes, against disease as well. Am I clear now, Praveen? Good. Values, these numbers are called observed frequency numbers. This is something which you observed in the sample. So this sample of 120 you have taken. This is you have observed. These are the observed frequencies. You make a table again. This is but in those tables you would match frequency numbers. So these are observed frequency numbers. No need to get a table. We have expected frequency numbers. What do you mean by expected frequencies? Expected frequencies, I mean frequency numbers within the null hypothesis. The hypothesis is there is no association between disease and exposure, and there is no exposure between disease and if there is no association between disease and exposure, not be any bias. The numbers should actually be like this. For this particular cell, the frequency number will be 50 into 4 120. Then, so observed, I will add another table which will have expected. So expected frequency numbers I am typing here. So this is the expected frequency number for this cell. So the expected frequency number will be 66 50 divided by 20. How are you able to understand this? For the frequency number would be basic probability is applied here. 70 divided by 120. It will be 6 90 divided by 120. Understand this. Frequency values, those values which are following, this is the null hypothesis, is there is no association. If there is no association, yes, Bindu. If there is no association, then there is no bias. It will be unbiased. So the probability we need to apply. I will explain it if you're not able to understand it. How many of you could easily? Exposure, no is the calculation, right? No exposure, yes means exposed. Disease, yes means they are found to be diseased. No, they are not found to be diseased. Could understand it. Able to understand. Balaji is able to understand. Okay, so a few people are able to understand. Amit could understand. Aditya could understand. Okay, so for could not understand, let me get into the granularity. First of all, what I'll state the null hypothesis. I have to explain it, and I will explain. Hypothesis here is that the variable v1 exposes v2 disease v and are independent. Two are independent is your null hypothesis. According to the null hypothesis, frequency values in the how to do that I'll show you. The number of individuals of exposed and unexposed group expected in each disease category, yes and no, if probabilities were the same. If there were no effect of exposure, the probability should be same. Let's look at the next line. In no effect of exposure, probability should be same. The population exposed is 50 by 120. There are 120 people. Okay, 50 of them are exposed. So of the population which is exposed is 42%, and 70 out 120 people are not exposed. So 58% of the people are not exposed. There is no effect of exposure. In a diseased population, it divided in yes and no according to this proportion only. The diseased population that will be again divided into this proportion only, into exposed yes and exposure no. Are you get it now? Good. You still have some confusion. Let me further get this. So, first of all, we should be very clear with what expected frequencies are. Expected frequencies are those frequencies, unbiased frequencies, which we are calculating if there is no effect of exposure on people. So, these two variables are independent. The frequencies we need to find out. And means the probabilities will be the same. So proportion of population which is exposed is 40%. 40% of the people are exposed, and 8% of the people are not exposed. Scenario. If you talk about people who are diseased, there are people who are diseased, and there are 66 people who are without disease. These two people, then no. In this proportion, irrespective of the two, be divided into, because you can't do anything about these numbers. These numbers are as it is. You can't the number diseased. They are as it is. Okay, should be there 42% by 100 into 54. That the case is no association. Are you now? Will calculate the expected and observed frequencies. If you're able to understand, I can rephrase and find some other way as well to explain it to you. But the objective is to to get it uh, simplified. Okay. So please let me know if you're not able to understand. So you have observed frequencies and expected frequencies. You will use this formula. So we've seen a few formulae. For Z, we have already seen how we calculate Z. Z we are using formula X bar minus mu sigma divided by root n. Seen how we calculate T. So I'm comparing the things here. Get again X bar minus mu, but in the T distribution we take the sample standard deviation. In F as well, F is variance and one column variance. Another statistic which is chi-square statistic, which is like this: observed frequency minus expected frequency divided by expected frequency, and that you do for all. So there were 4 cells. That for all the cells, 37 minus 22.5 divided by 22.5, like this. And you calculate chi-square value, and then freedoms are calculated, and from this you value and you compare the p-value. That is what you do. Very simple. Yeah. So let's use school these two variables. So there are people different kind of programs. Program. If the choice of choosing program is depending on the school. If a school and program both are categorical variables. If you want to check the hypothesis, that of program is depending on school or square test, CHISQ dot test you will use, and you these variables in this way, and you will answer. You would p-value here. The p-value is coming out to be, which is way too less. So you say that you can reject the null hypothesis. The null hypothesis was that program in school, these tables are not associated, dependent on each other. So it's called test of independence as well. So you can set program and school. These two variables are independent. The null hypothesis which you can negate. So the here would be test of program is actually dependent on the school. Are not clear with this. Hypothesis here, yes, you are right. Curve is used for categorical variables. So the conclusion here is the p-value is coming out to be 0.009, which is very less than 0.05. So p-value is less than 0.05. What is the significance level we are considering? You reject the null hypothesis. Reject the null hypothesis. The null hypothesis was that the variables are independent. The student program, these two variables are independent. You are rejecting. So I can conclude that the choice of program actually depends on the school. Yes, you are right. Need to go for other way around. So, he's solving the question. Test whether X. So, if you talk about that case study, whether the exposure is because of disease or not. So, it's always easy keep null hypothesis in a way with status quo. So is that nuclear plant is not affecting people's lives. Nuclear not affecting the health. That is the status quo, and that is why it was built over there. We have built it over there. Okay. So, keep the status quo in the null hypothesis to make the cal easy for us. The base that only we always keep the status quo. We are considering two independent variables, categorical in nature, and we are trying to find if the association between those two categorical variables. Okay. Now let's get into another technique. So we have just learned about categorical variables. If the variables would have been numerical, they are continuous. How about that? So this scenario. Anybody any question? We are getting into the correlation concept, and after regression, be able to only introduce with today. I might not be able to do regression in today's class. Then in this case, null hypothesis is less than 0.5 value, so nuclear plant is not affecting the people's status. Go no. Yes. case p value is less than 0.001, rejecting the null hypothesis. The null hypothesis was we will reject the null hypothesis. The null hypothesis was variables are independent of each other. The variables actually found to be dependent on each other. They are found to be associated. They are found to be affecting each other. So we will make people relocate from that location. Yes, you are right. Industry for KAIST. Okay, rail industry places at different locations on suppose you have one variable as the location and one as okay. Can be of three types. Other is lower and third is middle. So these categories have in location, and in sales again you have three categories: high sales, relatively low sale, and relatively moderate sale and relatively low sale. And you find these categories, you can form these categories by comparing the sale of that product with the average sale of the retail store. Now you have these two variables with you. If you want to check the sale of a particular product depends on its location or not. Sale of a particular product depends on its place or not, whether you are placing it at the top or middle or at the bottom. Categorical. And I can discuss it further if you have any question. I just don't want to rush through. Okay. Are you related, or you want me to get you for? Very good. So we have just seen how we can check whether two categorical variables are associated between themselves or not. You go for the chi-square test for that, and one which actually came to my mind. Can't apply chi test of independence for numerical continuous data. We can't do that. We'll be looking for correlation. Continuous data, I have just shown you. If you have the continuous data, like we had two variables in the retail store example. One variable was about the location. One was about the placement of the goods. If you are placing your product or in the middle or at the bottom. And the variable was about the sale. So C variable is continuous in nature, but if I had to apply the square test on that, I actually categorized that variable. I changed that variable into a categorical variable: high, medial, and low sale. Yeah. For categorical variables. Okay. About correlation. You all must have dealt with this thing at least at some point or the other, because this is used a lot. If you have not done the calculation, you've used it in your routine, in your life. So start with a very basic problem. Suppose you have, let me take the example of, just one sec. People are asking very pertinent questions. You people want to discuss the business, so that's why I'm able to you people. So here we have two variables, price and living area. I want to see the relationship. Relationship, I mean to say, these two variables are associated. Two variables are moving together. So to check this, let's draw. Oh, scatter graph. And right click, go to select data, add, see name, use, living values. So you look at this scatter diagram. What is this scatter diagram? Here we have price values on the y-axis, and x-axis we have living area. For different living area values, we are getting some price values on the y-axis. This is what it's showing, and these dots different records. So I agree with you. If you look at this, these all points, you see something, some trend you can observe, which is very explicit. It is very here. Relationship that trend you can see here. If you have higher values of areas, higher price values as well. Let me help you visualize it. So if you see the lower values of area, you get lower values of price, but higher values of living area, see, of price. So see, price increasing with increase of living area. Okay, so in a trend like this, will increase area, you are in the increased price values as well. So that price living area, these variables, these two continuous variables are found to be associated among themselves. We can say another point as well. We can say that they are positively associated, and now we have a name for that. That association is now called as correlation. So we can say that these two variables are positively correlated among themselves. Okay, this is one graph I wanted to show you. Let you another graph. Uh, but looking at the third and fourth row in exchange area and prices not matching the statement. The generic trend of the data. So I establish a relationship. Look at individual items. Always look at the overall data. So the overall data is suggesting us this trend, this relationship. Correlation is applied on the continuous variables. At a few things. For living area, I'll plot age. People are not very comfortable with Excel. They can also learn how to do the. So if you look at the generic trend here for age, so you could big statement, but looking for the trend here, then you can see. You can see values of lower values of price, and phase you are getting high values of price. that if price age is if it is old, the price is lesser. Is increasing, price is decreasing. So related again and negatively correlated. No, correlated. Are negatively correlated. So are you to understand now what is positive correlation and what is negative correlation? I will do the calculation part. I will explain you what to actually calculate it. That is another thing. But I only wanted you to understand the conceptual part. Good. For calculation, you actually arrive at uh, the number to decide something. So this is not very explicit, I understand, but it is suggesting you that for higher values of age, you are getting lower values of price. It is weird, but there is a trend which you can observe here. So pink in this curve is showing you the trend. There is a trend. They are correlated. Okay, what I'll do. Yeah. So let's discuss how we can find this out. So there's something called correlation coefficient. Coefficient. Coefficient is used to measure the degree of association between the two variables. Okay. Where correlation coefficient lies between -1 through 0 plus 1. Okay. The value is very close to -1. It actually means that they are highly negatively correlated. If the value of correlation coefficient is very close to +1, it simply means that they are highly positively correlated. If the value is close to 0, very positive, it simply means that the correlation coefficient might be out to be positive or negative, but the strength is very low. So we can find that out using Excel, and in R we will use it or function. So you will give an input and the second input a correlation coefficient. So this is the correlation coefficient between prime living area. And which is close to 1. I saw in the graph as well, it was pretty good. See the correlation coefficient between this and age in the answer to a question as well. So first element, keep as a segment, and here this give you the answer to your question. The negatively correlated that we saw from the trend, but the association, the degree of association is very less. It's not close to -1. It is close to 0. It is minus 0.36. Yes, association is not big. They are not. They are negatively correlated, but the degree of association is not that big. How many understand this point? So I do get into regression now. How mathematically? Do I suggest not to go for that in this class? But yes, you can go after the class and go for any book, and you will find over there that it is calculated using covariance. So you find out covariance, and then you divide covariance by the degree of freedom. The formula will again be different in different books. So you can test out on Google very quickly, and it's easy for you. So covariance, I never wanted to come up with the concept of covariance, and then I want then to explain the correlation coefficient, because ultimately you only be using correlation coefficient in the analysis. So that's what I was avoiding. So covariance divided by the degrees of freedom, that your coefficient. Okay, that's it for this class. I don't want to get into regression in today's class. For that, I need at least 20 minutes to get used with that. Okay, so that's it for today. If you don't have any question, we have to close the session. Have a wonderful week ahead. And yes, we have to get into some advanced things now, and you need to read at the concepts, the play we have discussed so far, so that you are comfortable in the next class. Otherwise, it will be difficult for you. For SAS class, I have not yet been informed when is my next SAS class. I'm taking one batch in the evening, which is in the midway, so that might not be helpful for you. I will be starting a SAS batch, but when I will start that, I am not sure about that. So you please get in touch with the certified team or sales people or account manager, able to guide you better. Okay, so I've not yet been informed about that. From analytics, I actually don't take classes. I only go for difficulty removal sessions for the corporates. So if you have any industry problems, I take the sessions and I help them solve that. Python classes, I think I will be starting with Python again. So I'll be starting with. Yeah. Good point. How you start with a raw data and go for the advanced analysis. So this is something, a very good point. Please raise this point of regression. Take this up. think this point. Yeah. And before you close the lid of your laptops, please participate in the survey. That is very important for me and for you as well, and for the Simply Learn. Please survey last is very important, which is about the NPS. Please attempt that. You can do all that thing. Okay, no problem. Thank you. Thanks. You here. Next weekend. Thank.
Morning. See, that's actually when I pulled out the report, no, the feedback was not generated. I must have done maybe